Hi guys, thanks for tuning in to another video on ForgottenWeapons.com. I'm Ian McCollum. I'm here today at the James D. Julia auction house up in Maine, taking a look at a bunch of the machine guns that they are going to be selling in their upcoming fall of 2017 firearms auction. Specifically today, we're going to take a look at this behemoth of a Gilded Age machine gun. This is a St Etienne model of 1907T heavy machine gun. Now the story of this really goes back to the late 1890s. The French military was investigating the machine guns that were now becoming available with the advent of smokeless powder. And like everybody else, they tested the Maxim gun. But one of the problems was the French had a lot of colonial possessions in Africa, especially in northern Africa. And the idea of having to carry water for the Maxim guns wasn't necessarily well received. At any rate, the Hotchkiss heavy machine gun was air-cooled, so it avoided this water issue, and the French government ended up adopting it. Not for the standard French infantry, but specifically for colonial troops. For the French infantry, they really wanted to have a domestically produced gun designed and manufactured by their own arsenals. There were a couple of reasons for this. One is simply national pride. One was the idea that you didn't want to be dependent on some commercial company for military arms. And I think they also, in a very practical way, simply didn't want to be paying royalties or profit margins to an outside company. They wanted to control all of the production and development themselves in-house. So, having done all of this testing of other machine guns, they set up to have the Puteaux Arsenal develop its own perfect machine gun. What they came up with was really quite far from perfect. The model of 1905 Puteaux was an air-cooled gun, like the Hotchkiss. It used feed strips, not the same feed strips as the Hotchkiss, but the same idea. We'll touch on these in just a minute. However, in order to avoid things like patent rights, the Puteaux machine gun was actually a gas trap design. It captured muzzle blast from outside the end of the barrel and actually used that to cycle an operating rod forward and operate the whole machine gun. Gas traps are a pretty unique system. They were used early on, not used by very many successful guns. The M1 Garand was originally a gas trap system, but it was redesigned before it really went into serious production. The Germans experimented with them with the G41 M and W rifles, but not a whole lot of other gas trap guns out there. So the French actually tried this with a heavy machine gun. Now, not surprisingly, that system didn't work all that well, and they spent a couple of years redesigning and redeveloping the gun, and what they came up with was this, the St Etienne model of 1907. Now, the big change here was they replaced the gas trap system with a gas piston system down here. However, it's a little bit of an unusual gas piston. Now, the mechanism of the Puteaux gun had been designed for an operating rod that was going forward. So it actually had this big rack and pinion system. It's extremely cool, and we'll take a look at it in a moment. But the whole mechanism is based on an operating rod going forward. So when they converted the guns, or redesigned the guns to use a gas piston, they had the gas piston go forward as well. Most of the time, gas is tapped on the barrel of a machine gun and it pushes a piston backwards. On these, it's tapped and pushes the piston forward. That seems unconventional, but really it's no more complicated to do than having the piston go back. It's just which way do you want to direct the gas when it comes out of the barrel. And by having the piston go forward, they were able to retain pretty much the whole mechanism at the back end of the gun without too much change. This model of 1907 machine gun, now, it worked a lot better than the Puteaux. It was a French arsenal designed and produced gun. Didn't have to pay royalties to anybody on it, and so this is what the French government adopted, or the French military adopted as its standard infantry machine gun, and this is what they had going into World War I. Now, the demands of World War I would require them to find additional guns, and so they ended up buying a lot of model of 1914 Hotchkiss heavy machine guns, which is what they'd been trying to avoid doing in the first place. But really, production of this, in fact, ended in 1917, and it would eventually be replaced by the Hotchkiss after the war. All right, I know we're going to get a lot of questions about the metallic feed strips. There are some rational reasons to use them. They are relatively easy to carry, they're compact, they don't rattle around so much like a belt does. You don't have to worry about water. On a cloth belt, if the belt gets wet, it can shrink. and it can then, cartridges can be very sticky in the belt and hard to extract for the gun. Metallic strips avoid a lot of those problems. Obviously, the big issue with the metallic feed strips is that they are limited in capacity. You could have a several hundred round belt, but with this, you're limited to 25 at a time. Well, these guns were run by crews, and you had an assistant gunner who was reloading for you. And it's pretty obvious where this feed strip is, how much ammunition is left in it. And you could run these things pretty darn fast, almost continuously with a two-man crew. So I don't know that the limitation on rate of fire, I don't think is as much of a problem as some people might suspect it to be. But it was enough of a hindrance overall that in 1916, or I think it was 1916, maybe a little later in the war, they did actually develop a 300 round cloth belt to use in these guns. So one of the other things that they did was in 1916, they instituted a number of changes to the gun. I mentioned at the beginning, this is a model 1907T. That T stands for transformé, or transform, the updated, adapted, transformed version of the gun. And this is a 1907T. They went back and retrofitted a lot of all of the existing guns to the new pattern. We'll talk about the changes that were made and as part of that a little later on in this video. Well, let's get started at the beginning. We have a gas piston out here. This taps gas off the barrel. Remember, we have a very heavy barrel here, and then this is a cast barrel jacket assembly to hold all the other parts to the gun. So inside this jacket, there is a gas port on the barrel, which taps gas down to here and vents it forward. Again, this was to avoid paying royalties to Hotchkiss for using his concept of the gas coming down and going backwards. So when the gun cycles, this piston is going to cycle forward in that housing, as you can see here. The gun is now cocked. The piston's all the way forward. When I dry fire it, that piston's going to snap backwards while the bolt snaps forward. We can see that actually working by opening up the side of the gun. So we have a locking cover here, and then a door that just gives us very nice access to all the internals. Now, the gas piston is this piece right all the way down here. You can see it's connected there to a separate part, so you don't have to machine all of this weirdness as one thing. But this is what's going to cycle back and forth when the gun runs. Recock it there. There we go. Now you can see the rack and pinion working. By the way, I'm holding the bolt here because it has a tendency to fall out if you cycle it without being careful when the door's open. Obviously, the door is there to allow the gun to be disassembled, so you can't really fault them for having it easily disassembled once the door is open. Now, when the gun's ready to fire, it's in the rearward position here, and you can see that this catch is the trigger. Let me hold the bolt back. Woo-hoo. There we go. It wants to fall out when I let go of it, so we're not going to do that. This catch right here is connected to the trigger. We have this is an oil pot here. This is a hydraulic rate reducing assembly. It can be turned on or off, and it can reduce the rate of fire from a maximum of 600 rounds a minute all the way down to allegedly 8 rounds per minute. Yeah, incredibly slow, like bolt action rifle fire sort of rate. And I did a little bit of testing, and that seems to be true. I'll show you that in a minute. However, we have a couple other things here going on that I want to point out. So obviously the star of the show is this rack and pinion system, which is just totally cool and weird, you know? Let me go ahead and close this. There we go. All right, now I've got this disconnected from the trigger again. What we have going on here is we have a lifter, kind of like in the Modele rifle. And we have an extractor right here, and we have our main bolt face here. And the way this works is when this goes all the way forward, this extractor is on a piece of spring steel right here. It is going to snap over the rim of a cartridge. This is where the empty end of the feed strip is coming out. So right at this level, we have live cartridges. This is going to grab one. It's going to pull it backwards. Actually, I need to cycle this forward. There we go. So it's going to grab one, pull it backwards, and deposit it onto this elevator mechanism right here. When the bolt's all the way back, right there. That elevator, which, by the way, is being pushed up by this little nub on the operating rod. I believe everything in this gun is basically run by protrusions and cams and things on this operating rod. Anyway, this elevator gets pushed up, and now when the bolt goes forward, the bolt head here, the bolt face, is going to, right about there, pick up the base of that cartridge and start to push it up into the chamber here. Now, right about there, the cartridge is securely held by the bolt face and the chamber, and so now the feed ramp drops back down, ready to accept another cartridge from the feed strip. Up here, we have the trigger mechanism cocking and uncocking. You can see, let's see, this lever right here is being held right there. When I let this all the way forward, it will drop, maybe, hold on. There we go. Now it has fired. So this is the system set up to only release the firing pin when the bolt is fully in battery. This fires from an open bolt. So it's normally, you would charge it and leave it at the rearward position until you're ready to fire. And of course, as with all guns, you want it fully in battery before the firing pin trips the cartridge. Now, the next question is, what actually locks this? The answer to that is this stud right here. So this whole piece right here that you can see me wobbling, this is all the bolt assembly. And this cam on this round cog acting in this track is what pulls the bolt back and forth. This turns, well, it's funny, it turns linear energy in the op rod into rotational movement in the cam wheel, and then back into linear movement with the bolt. But when it's all in battery, right there, the bolt is going to be pushed backwards by the force of firing. It is going to hit this stud here, and because of the geometry of this slot and where this is positioned, and this is just below the axis of this center line, this actually prevents the bolt from moving back until the operating rod itself moves back, which then runs this cam and pulls the bolt back manually. So that's how it locks. Hopefully, this has made a bit more sense of the internals of this gun, because I tell you what, they look super awesome when you open them, when you open this door up, but then when you actually try and figure out how this gun works, it can be a little bit challenging. As you can see from the tag here, this particular model of 1907 mitrailleuse, or machine gun, was made by St Etienne in 1910. It's number 932, and this is a pretty early gun. During the war, they would actually retrofit a number of features on these guns, and they went back and made these updates to older guns, like this particular one. One of those retrofits was to replace the rear sight elevation assembly with this cool, easy-to-use wheel. This thing tells you your range in hundreds of meters, so 600, 500, 400, and let's see, up here we got 7, 750, 8, 850, 9, etc., all the way up to, I believe we can go out to 24, 2300, toward 2200 is where it maxes out. If you look at the face of the rear sight here, you'll notice it has two little drilled holes. Those are for luminous night sights. There's one on the front sight as well, which is pretty cool. The French did that on rifles and also on these machine guns. I think the craziest, coolest, this is almost the coolest feature I have ever seen on any firearm ever, is this steel rod. And this is another one of the retrofits during the war to the St Etienne 1907 machine gun. Now the problem they'd seen earlier was that if you shot the gun a lot, of course the barrel would heat up, and this barrel jacket or body casing would also heat up. The problem is the two didn't heat at the same rate, and the front sight was attached to the barrel jacket or the body casing. So the problem they had is when the gun got hot, the barrel would get hot and move in one direction, and the sight would get hot and move in a not quite maybe the same direction or not the same amount. And the way that they solved this was to put a steel rod, it connects here, and it connects to the set of springs and levers up here. This rod also gets hot as the gun and the body casing get hot. it expands at its own rate, and as it does, it actually moves the front sight against this spring. You can see that I can push the spring down, and we have these levers that are moving in here. That's literally a calculated compensation mechanism to keep the front sight moving at the same pace as the barrel when everything starts to expand from heat. The amount of math and trial and error or calculation or material science that went into actually making that thing work, and apparently it did work, is really quite mind-boggling, I think. That is just such a crazy device that I don't even know what to say about it. So instead of saying more about it, I will point out that on the face of the front sight here, we have another little recess for radium paint to give you a glow-in-the-dark night sight. One of the other upgrades was a new style of adjustable gas port. You might say this is the gross motor skills version of World War I. They gave it this big rotating dial to adjust the gas system. And unfortunately, I think this one's missing a spring-loaded detent because it doesn't snap into place. But you have positions that are marked here from 1 up to 10, and you have varying sizes of aperture there, and they swing through this gas port system in the bottom. And so that is quick and easy to adjust. Presumably it doesn't get quite as hot as the barrel itself, or at least you have these pegs where you can use an empty cartridge case stuck on there or some other tool to adjust them if the gun's really super hot. Operation of the gun is actually pretty straightforward. It's going to feed from this 25-round strip. You would have cartridges in each one of these sockets. This is not interchangeable with the Hotchkiss 1914 machine guns. Keep in mind that when the French government or the French military was developing this gun, they anticipated it fulfilling all of their needs, and so there wasn't any real reason for them to make the feed strips interchangeable with Hotchkiss's commercially sold guns that other countries were buying. Anyway, you load this up, the flat side goes on top, and it feeds in with this solid edge at the front. So it goes in just like that, and it's going to slide nicely all the way through the action. I've pulled the clip out because I don't want to accidentally damage it with the feed spool rotating while we're demonstrating this, but you would put the feed strip in, and then this is your charging handle. You're going to pull out on this handle bit to release it, and then comes all the way back. That has locked the bolt in the rearward position. It is now ready to fire. And just like a modern non-reciprocating charging handle, you've got this thing floating out here loose, and so you want to make sure to snap it down before you pull the trigger. When you do pull the trigger, the bolt will release, snaps forward, and fires. This is our rate-reducing mechanism. When it's pushed in like this, it is off. When I pull it out, that engages the rate reducer, and then this dial allows me to determine the rate of fire. All the way forward is fast, all the way back is slow. Think of it like an accelerator. And this rate of fire is actually slow enough that I can demonstrate it to you. All right, the gun is now charged, and I am going to perform what is basically the standard test for determining if a gun is full auto. Namely, charge the gun, pull the trigger, hold the trigger down, and then manually cycle the action. If the bolt goes all the way forward and the gun dry fires, that means that it would have fired fully automatic. If the bolt gets locked to the rear, it means you're in semi-auto. In this case, what I will be able to do, because I have this delay mechanism set to the slowest possible setting, is I will actually be able to cycle the handle and put it back almost fast enough to beat the bolt forward. That's because that little hydraulic buffer system here is holding the trigger engaged for really quite a long time. So here we go. That's the first firing, and then you can see how much delay there is in that. I don't know if that's quite 8 rounds or 6 rounds per minute, but, well, it's definitely not. It's not an 8 or 10 second delay, but that is an extremely slow rate of fire. That's probably 50 rounds a minute or less. This is, without a doubt, in my mind, the coolest muzzle device ever developed for a firearm ever. And these things get a lot of questions when they come up because, man, that is a weird device. What exactly is this shield for? Well, we can get an idea by taking this thing off. This is actually both clamped and threaded on. So I've undone the clamp, and now I need to unscrew this.
By the way, later on they would develop just a simple conical flash hider that did just as good a job apparently, but this cool thing was out during World War I. So what this is actually doing is the muzzle ends here, and this gives the flash a nice long channel in which to mix with air, burn off, and not show up on the outside. There are actually a couple of open slots on this tube inside this shield. You can see them right there. So what they're intending to happen here, and I think it did work, although I haven't actually tried one of these out, is the flash is going to come out the muzzle down here into this tube, and it's going to come down, and you'll see the flash come here, and that's what this shield is for, is blocking view of the flash. It's kind of a flash redirector down into this bottom area where it can then be burned off and dispersed and doesn't create any visible light from the front. I have taken the gun off of its mount now, so I can show you some of the other elements from the bottom. Notice, interestingly, that the whole bottom of the receiver has openings in there to, I guess, cool it or reduce weight. I guess the idea was they didn't figure there was that much danger of dirt getting in vertically from the bottom. Don't know if that actually caused a problem in combat or not. All right, and then here's something really cool. We have two latches right here. I can open those up, and then I can take this cover plate off, there it is, off the gun, and now you can see the feed assembly. So the operating rod actually runs linearly through the center axis of the feed spool. These hooks are going to catch on the cartridges, and that is what pulls the strip through the gun. Because of the ratcheting system here, when you cock the gun, when the bolt goes backward, nothing happens here. When the bolt goes forward, this indexes one position each time. Now, what you have to remember though is when the bolt's going forward, the charging hand or the operating rod is going backwards, because this works in the reverse of most modern machine guns. So there is also this lever right here, which disconnects our ratchet system and allows this to spin freely. So when you have this thing installed, you can still get to that little lever right here, and you would push that forward, and then you can grab the feed strip and pull it out of the gun even if it's partially loaded. So that is your manual unloading button. But man, just the amount of steampunk in this gun is kind of mind-boggling and just really impressive. All right, when it comes to heavy machine guns, we can't really talk about the gun without also talking about the tripod. A lot of people may look at this as just some sort of accessory for standing it up in your living room, but in actual combat use, the tripod is nearly as important as the gun itself. If the tripod's no good, you won't hit anything with that gun. This determines how stable the gun is, how smoothly the gun can actually be fired, and really determines your ability to make hits at long range. So, this is the standard 1915 omnibus tripod that France used. This tripod was set up to work with basically all of the machine guns France used, primarily the 1914 Hotchkiss and the 1907 St Etienne, as well as the 1905 Puteaux. And it's got a couple of controls on it. The obvious one here, and the most recognizable, is this giant wheel. This is your elevation wheel, which allows me to crank the gun up and, well, down and up. This has this really nice compound nested coarse threaded screw there. It's really smooth, and this works really nicely and well. On the other side here, we have this handle. This is the traverse lock. When it's forward, the gun is pretty much locked in position. When I pull this back, it unlocks the gun and allows me to pivot it side to side. This tripod also allows me to very quickly and easily attach or remove the gun. So there's a button right here. I can push that and quickly detach the rear elevation control. I can then also very quickly open up the front trunnion attachments. I pull down on this button and then just rotate that screw. And what that does is unlock the trunnion from the tripod. So if I do that too, both sides. There we go. This can be easily done by one person, as you see. Now, the front trunnion is just sitting in the tripod, so it's loose there. I can pick it up and take it out of the tripod. Why would I want to do that, you ask? Well, perhaps we want to use the gun in an anti-aircraft mode. I detach these 3 connections. I can then grab the gun, reverse it on the tripod, snap those 2 connections back in place. The gun is now locked back on its mount. Open that, and now I have a free elevation and traverse machine gun for anti-aircraft fire. If this tripod setting is too high and exposing you to too much fire, you can pivot these 2 levers, and then you can actually fold the legs. If I can, this is not so much of a one-man operation, but there we go. We can fold the legs down like that, and now we have a much lower profile setup for the tripod, and we still have 2 little feet here to dig into the ground. If said ground isn't quite level, we have a threaded adjustment on the right leg, which can be used to lengthen or shorten this leg, thus allowing you to level out the tripod. Standing this up to look at it, you can see we also have these 2 clamps, which allow you to lengthen the rear leg, again, to get better grip in the terrain or to have a better angle on your setup. Now, those 2 are pretty tight and looks like they haven't been moved in a very long time, so I'm going to leave those 2 alone. And naturally, the whole thing folds up for transport when you're moving the gun from one position to another. After looking at the mechanics and seeing how this whole thing works in theory, I guess the big question that remains is, how did these actually perform in combat? How did the French like them in World War I? Well, the answer is not super great. This is a fantastic Gilded Age type of mechanism here, and when it's clean, this is the sort of gun that I think will just pretty much run forever. It's exquisitely well manufactured. The problem is, it's not really designed for the stresses of modern combat. Something like a Napoleonic battlefield, this would be fantastic because you'd fight for a day and then you'd go back to camp and you'd be able to clean the gun and replace anything that might have broken somehow and keep everything in tip-top shape. Well, the problem is World War I was not Napoleonic combat, much to many people's surprise. The mud and hell of World War I didn't play well with guns like this one. And so these did have reliability problems when they started to really get dirty. And that was an inevitability in World War I. So by 1917, production of these ceased. They did in total make about 41,000 of them. About 11,000 were made by the Puteaux Arsenal, and another 30,000 roughly, give or take, were made by St Etienne. They were used by a couple other countries in small numbers. Romania apparently bought some, and then the Italians and the Greeks both used them during World War I. But the French Army replaced these with the Hotchkiss 1914 heavy guns, which were a lot simpler and, as a result, more reliable in the field. That being said, you really can't help but admire the craftsmanship and the workmanship that went into manufacturing a gun as, I don't know that there are words beyond exquisite for how this thing was put together. Does that mean it's a good combat gun? No, clearly not. But man, it is a cool gun. There are not very many of these in the United States, not surprisingly. This one is registered, fully transferable, and it's coming up for sale here at James Julia. So if you would like to be the first one on your block with the world's most awesome steampunk machine gun ever, take a look at the description text below the video. You'll find a link there to the Julia catalog page on this gun. You can see their pictures and description and paperwork and all that sort of stuff. And if you'd like to have it, you can place a bid live here at the auction in Maine, or over the phone or through the website. Thanks for watching.